FRQ says, consider the family of functions f of x equals 1 over x squared minus 2x plus k, where k is a constant. Part A says, find the value of k for k greater than 0 such that the slope of the line tangent to the graph of f at 0 equals 6. So I took the function f and rewrote it as the quantity to the negative 1. So now we can take the derivative by using the chain rule. Remember, when using the chain rule, you're going to bring the power down, you subtract 1 from the exponent, leave the inside the same, and then times by the derivative of the inside. Okay, at this point I took this negative, distributed to the 2x minus 2 to get negative 2x plus 2, and moved this expression to the bottom. Okay, so this is the slope of the tangent line. We set it equal to 6, so you plug in 0 for x, and then when you simplify, you get 2 over k squared equals 6. So now this is a proportion. I'm going to cross multiply. So you get 2 over 6 equals k squared. And we get to here, it says k is equal to plus or minus the square root of 1/3. It also notes that k is greater than 0, so therefore we're just going to take the positive answer. So we end up getting that k is equal to positive square root of 1/3. Part B says, for k equal to negative 8, find the value of the integral from 0 to 1 f of x dx. So f is equal to 1 over x squared minus 2x plus k, and we're going to plug in negative 8 for k. Alright, so we get the integral from 0 to 1 of 1 over x squared minus 2x minus 8 dx. The denominator factors, you get x minus 4 times x plus 2. So now we're going to use partial fraction decomposition. So you take the fraction 1 over x minus 4 x plus 2, and we're going to split up these factors in the denominator. So you have one fraction as x minus 4, the other fraction's denominator is x plus 2. Because both of these are linear factors, we're going to use just a and b in the numerator. At this point, we're going to multiply the whole entire equation by the least common denominator. By multiplying both sides of the equation by x minus 4 times x plus 2, these will completely cancel out. You just get 1 on the left. These x minus 4's cancel, so you get a times the quantity x plus 2. These x plus 2's cancel, so you're going to get b times the quantity x minus 4. Okay, I distributed the a, I distributed the b, and then I moved the terms with x together, and then I moved the terms that don't have x over on the right. Okay, at this point, the coefficient of x is a plus b, and you'll notice there's no x over here, so that's why I set a plus b equal to 0. The constant values are 2a minus 4b, and you set that equal to this constant on this side, which is 1. And now we're just going to solve this using elimination. So using elimination to solve this system of equations, I multiplied the negative 2 to the top equation. You get negative 2a minus 2b equals 0. Just rewrote the bottom equation. By doing so, your a values drop out. You get negative 6b equals 1, therefore b is equal to negative 1/6. Take that, plug that back in, and solve for a. So you get a is 1/6. Now we're going to take these values and plug them back in to rewrite our original integral. So we plug 1/6 in for a and negative 1/6 for b. So we get the integral from 0 to 1, 1/6 over x minus 4 plus negative 1/6 over x plus 2 dx. These both have 1/6 in them, so I'm going to factor 1/6 out and pull it to the very front of the integral. And at this point, to integrate, you could technically let u equal the denominator. If you take the derivative, you'll get 1. So then you have 1 over u, and then you integrate that, and you get ln absolute value of u. And then we're going to plug the u back in. Just a reminder, when integrating, if you let u equal the denominator and you take the derivative and you get a value other than 1, you might want to split up these integrals and then actually change your upper and lower limits when you do so. So just be mindful of that. Okay, at this point, we're going to plug in 1 to everything minus plugging in 0. So we get to here, now I'm going to keep simplifying. So right here I condensed, so you get ln of 2 over 4, and then your final answer is 1/6 ln of 1/2. Part C says, for k equals 1, find the value of the integral from 0 to 2 f of x dx, or show that it diverges. When you plug in 1 for k, you get the integral from 0 to 2, 1 over x squared minus 2x plus 1 dx. So at this point, look at the denominator, and that actually factors. So you get the integral from 0 to 2 of 1 over x minus 1 quantity squared. What you'll notice is this rational function has a discontinuity at x equals 1, and x equals 1 is in the interval from 0 to 2. So I split up the integral where the discontinuity occurs at 1, and at this point you can work either integral. I'm just going to work this one on the right. Okay, if you think of a number line from 1 to 2, this is representing the area under the curve. 1 is the value that's causing the problem. So if you think about your interval, you're approaching 1 from the right. So that's why I wrote this as the limit as t approaches 1 from the right, and then replaced the 1 with t. And now we're going to continue integrating this part. So I'm bringing this denominator up and rewriting it with a negative exponent. I'm going to let u equal the inside function, so you get u equals x minus 1. take the derivative and you get dx is equal to du. Finally, I'm going to convert my upper and lower limits. Okay, and we're ready to integrate. So I brought the negative to the front. You have the limit as t approaches 1 from the right of 1 minus 1 over t minus 1. At this point, think about this limit as you're approaching 1 from the right. This function looks like this, so approaching 1 from the right goes to positive infinity. So you end up getting that the limit does not exist, therefore the integral from 0 to 2 of f of x dx diverges.